Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please to consider subscribing. On this particular video, we're going to see how to use the formula for the derivative by first principles to find the derivative of a function. Let's start. We've already seen this formula in the earlier video that the derivative of a function denoted by f prime of x is given by this formula limit as h approaches 0, f of x plus h minus f of x, the whole thing divided by h, and this is called the derivative by first principles. This is the formula for the derivative by first principles. And on this video, we're taking some examples. Let's take two simple examples to start off with, okay? So this f of x, the first example, f of x is given by 2x squared minus 5, all right? Now, in order to use the formula, we'll just write down f of x plus h first. Okay, so that would be just replacing x by x plus h. You'll get 2 times x plus h, the whole square, minus 5. Simplified further, you'll get 2x squared plus 2x times h plus h squared, close brackets, minus 5. Can you see this? All right, let's simplify it further. You'd get 2x squared plus a 4xh plus 2h squared minus 5. Now we'll work out the numerator of that term, okay? The derivative by first principles, you've got the numerator f of x plus h minus f of x, okay? So this goes in nice orderly fashion. So f of x plus h minus f of x, that would simply be 2x squared plus 4xh plus 2h squared minus 5. That's just the first term. Let me just zoom out a little bit. That's just the first term, minus f of x happens to be, I'll put that into brackets, 2x squared minus 5. Okay, now when we simplify this, you should get 2x squared plus 4xh plus 2h squared minus 5 minus 2x squared plus a 5. And that, when you simplify, you can see that 2x squared, that gets cancelled off, and this 5 also gets cancelled off, and this reduces to 4xh plus 2h squared. That is just the numerator, so that when we combine it with the denominator to get f of x plus h minus f of x, the whole thing divided by h. This is the difference quotient, by the way, okay? This is the formula for the average rate of change. So this is just called the difference quotient. This would be 4xh plus 2h squared, the whole thing divided by h. And then you can factor out h from the numerator to get h 4x plus 2h. On the denominator, we have that h, and those two h's can cancel off, so that this difference quotient is 4x plus 2h. Clear? Now we have to find the limit of the difference quotient, which is the formula for the derivative, right? So f prime of x is equal to limit as h approaches 0, fx plus h minus f of x over an h, and that happens to be limit as h approaches 0. That term we've already calculated, and that is 4x plus 2h. Now when we put the limit for both the terms, when we take the limit for both the terms, the first term does not have any h, so that's just going to be 4x as it is. And here when we put h equals 0, you'll get that term just goes off, and so this limit is just 4x. So the derivative f prime of x for the function that was given to us as what was the function? It was 2x squared minus 5. That was the original question. The derivative by first principles comes out to be 4x. Clear? Let's take one more example, okay, using the same method of first principles, all right? So we'll take this second one, which is 1 over x. Okay, so I'm going to do that question here. Let's put a line, and we've got f of x as 1 over x. I like to do it that way orderly, so that you just don't get muddled directly going to the formulae. So we can do it step by step that way, right? So you can write f of x plus h first. This is going to be 1 over x plus h. Okay, just replacing x by x plus h. Now combine the two terms to get the numerator of that difference quotient. F of x plus h minus f of x would be 1 over x plus h minus 1 over x. Okay, can you see this? Cool. Now let's take the LCM. You should get the denominator as x times x plus h, and then when you cross multiply, you get x minus x plus h. The numerator of this term now reduces to x minus h, and the denominator we've got x squared plus xh. The numerator, you can get that x is out, and this reduces to a negative h And the denominator, we've got x squared plus xh. This is just the numerator. Remember, this is just the numerator of the difference quotient. Okay, this is f of x plus h minus f of x is just negative h over x squared plus xh. But we need to now divide it by h, right? So f of x plus h minus f of x, the whole thing divided by h will just be this term. So I'm just going to write it like this. Okay, so I'm just going to write it as negative h over x squared plus xh, right? The whole thing divided by h. And then when we work it out, we'll get negative h over x squared plus xh times 1 over h. Can you see that? That's the difference quotient. Now we can see clearly that that factor of h from the numerator and the denominator cancels off. This reduces to negative 1 over x squared plus xh. That's the difference quotient. That's the difference quotient. And then we can say that the limit of the difference quotient, which is the derivative of the function, is just taking the limit as h approaches 0, f of x plus h minus f of x, the whole thing divided by h. That should just be limit as h approaches 0 of this term. We've just calculated that, right? So this is going to be just negative 1 over x squared plus xh. And as you can see, when you put h is equal to 0, you can just substitute h equals 0, right? This term will go off, right? That term will become 0, so that the limit just reduces to negative 1 over x squared. So the derivative of the function, the original function was 1 over x. 1 over x, the derivative of the function 1 over x reduces to negative 1 over x squared. How did you do that? Well, step by step. The formula for the derivative by first principles was f prime of x is limit as h approaches 0, f of x plus h minus f of x over h. My tip would be do it in an orderly fashion. Write down first f of x plus h, then work out the numerator, f of x plus h minus f of x. There's a lot of algebra happening, so you can reduce it to some form, then divide it. Okay, that's the difference quotient. Then divide it by h, that reduces further, and then take the limit and write it as f prime of x. So this is how you find the derivative of any function using the formula for the first principles. If you found this video helpful, make sure that you like, share, and subscribe to this channel. I'm going to see you all on the next video.